Before I start, I want to introduce myself. So, my name is Otmar Jatsch. I work in this building for MSG. I'm part of the technical guidance group, and we do exactly what you think we should do. So everybody has some imaginations now. Very good. You can contact me through email or via Twitter if you want to. So, the agenda for today will be 3 parts. I will talk briefly about server computing, then serverless computing, then I will talk about serverless architecture, and then I will show you something on AWS Lambda, what we have done. So first question is, who is already familiar with AWS? Who has done something, who is running his application on AWS? Okay, some of you, yeah, especially those guys over there. Anybody who has done something with serverless functions already? Okay, again, some people, not that bad. Now, I have a quote here. It says, and if you read something about serverless computing, you will find this quote quite often. It tells us serverless computing is the next evolution of cloud computing. Why is this the case? That's a slide you probably have seen in the internet quite often. If you look at an application you want to run somewhere, you could break it down in a lot of sections, and I have 4 here. You have an infrastructure where you run those your application on. You need a middleware where it runs inside, so a web server or runtime, or maybe some databases, mail servers, whatever. You have your application, and we have here an additional layer because I need it for serverless. We have functions here. So your application normally consists of a lot of functions. In the old times, and the old times are not that far away, everything was running on premise. That means that you were responsible for running your application, running your servers, and if you look like it is right now, this was quite a hard time, especially if you were working in a big company. Then it could take you months to get your application running because of the order process about the server that took months. And when you really wanted to get up fast with your application, you weren't able to do that. So then, some years ago, the infrastructure as a service showed up. And I cannot say it really is ugly head because it's a very nice head. You were able to provision infrastructure by pressing a button. You had it in some minutes, or today you have it often in seconds, to get an infrastructure, and that made it quite easier to get started with your development. Then those IaaS providers thought that it would also be a nice idea to provide some additional things, and so they introduced those platform as a services. You would not only get your infrastructure, but you were able to get build packs for your middleware, so you were able to get a Node.js build pack already installed on your machine, or a Java web server already installed. And additionally, those platform as a service providers also gave you software as a service, so they provided you services that you can use. And for that, you were no longer, or you were no longer in the need to install or administrate your database your own, but you could just use it through a software as a service. And a lot of other services that you need normally to run a web application, something like authorization and so on. And now we come to serverless. So what's the difference? If you look at it, you see one difference directly here, and we'll talk about the other one. If we look at platform as a service, the unit of scale was the application. When you try to scale your application, let's say in Cloud Foundry, you give him a CF scale my application up to something. So the unit of scale is the application. You scale your backend normally. If you look at cloud applications. Right now, if you look at serverless, the unit of scale is the function. What does that give us? Let's say you have a backend that is running quite smoothly, but you have one function that takes all your CPU, and you have a problem now, and you have to scale out. But the thing is, you are only scaling out because of that one function that kills your application, more or less. And otherwise, your application would run quite smoothly. And now with serverless, you have the possibility just to scale that one function that has a problem and let the others run as they are right now. This is one difference between platform as a service and serverless. And the other difference is that the responsibility for the infrastructure is even more pushed to the cloud provider. If we talk about serverless, you just give the code to your cloud provider, and the cloud provider hosts it for you. And you don't even have the possibility to access those servers where he is hosting this code. So you don't have the possibility to SSH on that machine and configure something. They are in charge for letting run your functions. And they are also responsible that your functions run smoothly, that they are always available, and they also are responsible to scale out if your functions are no longer available because of too much traffic. So where are the responsibilities here? If you look on the left side, you see the cloud provider. He fully is responsible for ops, for the operations. He is responsible to provision the servers where he wants to run your functions on. He is responsible to do the whole server management. He is responsible to make your function available all the time, 24/7, without no downtime. And he also is in the responsibility to scale out if your function is no longer available. Also, because you are not able to grab that server where your functions are running, they have to provide you with additional services. For instance, logging and monitoring. Normally you want to see how is my function running, do I have problems with it. If you don't have access, you cannot set up a monitoring application that monitors your functions. So the provider has to give you these services. So what's the responsibility for the cloud developer or the company that is developing an application? They just have to code their application or their functions, and they have to pay for it, obviously. And the pay-per-use, it's a pay-per-use system here, so you only pay for each function that is called. You have to pay a special amount, and you don't have to pay them that they have their servers up for you. Okay. What's next? I have to check. Okay, so any questions so far? Because that's more or less chapter 1 for today. So, okay, so what does that now mean for a serverless architecture? Or what possibilities do you have now with the understanding what serverless computing is? So if you look at architecture, how it is done right now, yeah, I have 3 possible architectures here. That's the old style, or very long and old style, is the monolith, where you have all the functions in one unit of deployment. Obviously, when most of us probably have developed a monolith, I see at the right side they are all laughing.
The left side is current.
Oh, it's current, okay, sorry. Yeah, it's current for us as well. So. Yeah, you have all the problems with a monolith that you can have. First, it's always a good approach, probably, to just start with a monolith, as long as you're not able to grab your domains so that you can start with microservices, so it's not that bad of an approach to go with a monolith, but then you have the problems you have. Additional coding you want to get in there, maintenance, whatever, scaling, everything. So it was like this. So we have one unit of deployment with a monolith. Now we're talking about microservices. That's also maybe a buzzword for the last 5 years or 4 years, something like this, where you try to cut your application into domains, and then out of the domains try to craft some microservices. So microservice could be one domain, or it could be an aggregate of domains, depending how strongly coupled those domains are. And you let those domains or those microservices talk about some well-defined APIs, and you have a lot more units of deployment now. But that also gives you a lot of problems. Yeah, so this is something what we hear quite often is, especially from people who don't know exactly what a microservice is. I did not say management right now. They are always proposing, let's do it with the microservice approach. But it doesn't make sense all the time. Yeah? And especially they don't have a clue what problems you get when you try to go this way. And now we are here at serverless architectures, or you could call it nanoservices. Now your unit of deployment is just one function. Let's define a microservice again. I forgot that, sorry. We also are talking often about self-contained systems. So microservice could be a self-contained system. So what does it have? It has a backend. It brings the UI for that backend. It also maybe has a database. What's the database only just for this microservice. And the backend normally at least has all the CRUD functionality plus a lot of other functions normally. And so you are here with, I don't know, 10, 20, 30 functions. And now you split it up and you deploy each function for its own. So it's the unit of deployment is just one function. Looks again very difficult, right? It is. Okay. So what is such a function if we try to define it? It's a small, discrete and reusable piece of code. Can we maybe at some point it doesn't make sense to have that much line of code, so if you put too much into a function. And it is, as I said already more than once, this is the unit of deployment, what we have here. Also, function is always stateless. Okay, that's nothing new. We already know that. Developing web applications, and we have a backend, and most of the time, this should be stateless. So nothing new, but it also brings us all the problems that you have with the stateless API. Yeah, you have to always load at the start of the function that is running maybe some data from the database so that you can do something on it and then save it back. Yeah, maybe. Yeah? So because you have no cache anymore, you don't give all the data from the front end to the back end, just maybe an ID, and then you first have to load up the data and then do something with it. So that's some problems you can have with stateless. What are serverless functions as well? They are short-lived and should be fast executed. Especially on AWS Lambda, there is a limit for, I think probably on all the other cloud providers as well. There is a limit how long a function may run. And if you are not able to run the function in that time, then AWS will just kill your function and give a 500 back to the caller. And the time here is, I think, 300 seconds here. It's 300 seconds, so that's max. So 5 minutes is quite long for a function, but you also have to pay that for this, and you should think, is it worth? So to get really nice prices, you should have functions that just run in the millisecond, 100 milliseconds duration time, and not run for seconds or even minutes. The functions normally are triggered by some events. Or should be, yeah, they are triggered by some events. You cannot really call a function, there is a possibility, but you just can't call it on its own. You can call it with AWS SDK directly, but normally you have some event in front of it. Yeah, you have an SNS, a notification service in front of it, or you have API gateway, so a REST service API that calls this function. And one really characteristic of serverless functions is that they use services. So we just have some code, some small function. And in normal circumstances, you just don't want to calculate 1 plus 2. But you need additional services. You need data from a database. You want to fire an email. You want to send an SMS. So you need additional services that this function normally calls. And this is one of the characteristics, and this is also the way that sometimes serverless architecture also gets the name backend as a service or function as a service. Yeah. So that's an explanation what a function is. And next, on the next slide, I want to talk about when could I use that? When does it make sense to use functions? So first off, I don't think it makes sense to write a real application, or especially an enterprise application with function as a service, because if I look at MSG enterprise applications, they have 10,000s of functions. So how should you get all that connections running? I think that's impossible to do right now with the technologies we have it right now. But what could you use function as a service? A very good example where you can use it is if you have the possibility to isolate some functions inside your application that are easily isolated, that don't have much coupling with the rest of the application, and let them run as functions. Especially if they are a problem for you. Because then you have the possibility to scale only this function and leave the rest of your application untouched. Other good use cases are schedule tasks, so batch runs, something like this. They are always quite painful to have it in your application, so that's what I think. Maybe some say no problems with that, but I think it's because it's not fitting into your web application most of the time. So most of the time you don't even have it in your application, but you maybe have some cron jobs or something like this that do it. And here you have the possibility to do that over function as a service. Other things, asynchronous tasks, things like file upload, something like this, where you don't need the response immediately. That's also a good use case for function as a service. You can use them for some REST backend. I also wrote a book about one of the gurus of serverless stuff. They made a whole application. It's an education platform in the US. They wrote that completely as a function as a service application. So it is possible, as I say, I think, well, it's quite hard probably to do it. But another use case probably is very good is an IoT backend. Yeah, so IoT backends where you want to send some data from some things from your variables. You don't need that much functions normally, so 2, 3, 4, 5 functions are easy enough. for your IoT backend, and then that's just a good use case. And another good use case, and this is what we use here in a project, this is for continuous integrations or continuous deployment events. So we have a web application running on AWS. We are using the pipeline, how's it called? CloudFront? No, CloudFormation? No. So the service that you can make a deployment pipeline, and we use that for our test systems and also for the production system, and we inform the developers about some steps that happen inside that, especially if something is not happening, and we then send informations into our Slack channel, so they don't have to have AWS all the time up to see if there is a problem, and we don't have to send some emails. We could do it with emails, we could do it with SMS and stuff, but we decided just to write those information into Slack, and yeah, it's working quite good. Also, we are for production, we have a lot of alarms configured. If we think we have problems with our application, and whenever an alarm triggers negatively, then we also send this information to the DevOps team, so they know there is a problem. Okay, so let's get to AWS Lambda. Right? Yeah. Okay. Okay, time is good. Of which parts does an AWS Lambda function is built of? So there are three parts in this building. First, we have the event. The event is the trigger that triggers your function and executes it. Then we have the function itself, obviously with the code, and then the function normally, in 90% of the time, uses some resource that it needs to execute. So what do we have to do on AWS Lambda to get this running? I will show it in a real example, but also on the slides. First, you have to configure your trigger. So how do I want to trigger that function? And as I said, you can trigger it directly through AWS SDK, but you can use a lot of different AWS services to trigger it as well. So here you can see some API gateway for a REST API, SNS probably are the two most, and CloudWatch are the three most used services to trigger some functions. Then you have to upload your function, obviously. Right now you have 4 programming languages that you can use to write those functions. You have Node.js, I think it is 4 and 6, I'm not quite sure. You have Python 2 and 3. And you have Java 8 and C# as programming languages to implement your function. So I only tried around, or we only were working with Node.js. And then you can, but don't have to configure your function. So you can also run with the default settings, but there are some possibilities to configure. So I also put one additional point here on the slides. It's about the costs. So how much do you have to pay for AWS Lambda? And it consists of 3 points. First, it's the number of requests. The more requests I have, the more I pay, obviously, because it's pay per use. And how much is the price for one single call? It's depending on 2 characteristics. One characteristic is how long does my function run, so the execution time. It's rounded up to 100 milliseconds for each call, and the memory I've allocated for my function. It starts for 128 megabyte, and I don't know exactly where the limit up is. So what you should look if you want to have a very cost-efficient function, you have to have functions that are running shortly and that don't need a lot of memory. So when you can get that down, those things, then those functions are quite cost efficient. And now I want to show you how to do this. how it looks like if you are in AWS Lambda. So I'm here on a test account. Here on services, Lambda, I have 4 functions. This will be my scenario I will show afterwards. But how do I create a, sorry, okay, I cannot make it larger. So you can create a function. You can take a template. They have some templates here, but I just will do one from scratch. I have to give it a name. My test function. And I also have to choose a role for the execution. And then I get to the beef, but it's not much to configure. So here I have the possibility to even write the code directly in the browser. That makes maybe sense if the function is very, very small. If you want to, or if your function has some more code, you can upload a zip file or upload from S3. I think zip file has a limit on 10 MB as far as I know, and you also have a limit, I think, on 50 megabyte on the function you have. Maybe you can make a ticket and ask for more. But right now it is like this. Why do I need this? You have all the dependencies that are on Node.js or the AWS SDK. You have that available, so you can require it directly without uploading those dependencies. But if you want to use some other dependencies, you have to upload them in the Node modules folder, as most of us know. So yeah, so that's necessary. I just will write a very simple thing. I will just console log something. I will show better coding later. So. Okay. I also will tell him which is the chosen runtime. Also, the coding has to so there are conventions how you have to write your code so that they understand what the function is that you want to call. So here I have to configure which of my functions inside that code is the real function that is executed. And then I can do some additional stuff. For instance, changing the basic settings. So here I can allocate the memory I need. Let's see what this is. Okay, 1.5 gigabyte RAM is the max right now, and the lower I can go, the less I pay. And also I can define a timeout. It's default on 3 seconds. You can go up to 300 seconds, but you always have to have in your mind if the execution of your function goes over that limit, then it will be killed. Okay, and that's it already. Okay, no, I showed one more stuff. I talked about the trigger. So I have to configure the trigger for my function. And I have a lot of services here available that I want to use. Let's say I use the simple notification service from AWS. And if I have already created a topic in SNS, I can just choose it and then enable this trigger. And it does nothing else in this case that this Lambda function subscribes to the topic, and whenever the topic is fired, the function is executed. Okay, let's disable it for now. Okay, let's save it. What's also quite handy here is that you can test or make some tests. So we test here from the browser directly. You can give him a JSON as the event input parameter. I'm not using it. I just console log something, so I don't care what's in there. I think I have to give it a name. Okay, now I could trigger my function with this test data and see if it works. If it works, okay, it was quite easy. Why should it not work? Two things I want to show you. Now, where can I see this log that I just created, or that log entry that I just created? They have to give you access to that, and it is logged in CloudWatch, in the logs, and here in a special log group, log stream, and I can check this out and see also some additional information in the log for each of those functions. So I see how long has it taken. This was 60 milliseconds. I'm built for 100 milliseconds because it's always rounded up to 100 milliseconds. How much memory have I allocated and how much have I really used? And maybe that's also a good starting point to see how much does my function under normal circumstances costs, and then I can change my configuration of that. And you also see the log entry that I did. Okay. And also maybe it has, I hope it has updated already. Yeah. So I also get some monitoring here, especially about the invocation count, how long does the execution takes, how many errors do I have, and so on. So they also provide me some monitoring, and I think, as far as I know, I can show or look at more information. But here in this dashboard, only these 6 aspects are shown. Okay, that's how easy it is to get a very simple function running. And then I made a bigger scenario. Okay. It's also not that hard. But what I have done, I just made a small, very small HTML application, plain HTML, that I host as a static web page on S3. It is a contact form where you can send some information to someone. It's making a post request on the REST service that I host here through API gateway. And that API gateway just calls the Lambda function. You can also say that's the implementation behind that REST service. And the function does nothing else but trigger an event and publish the topic in simple notification service. And I have 3 Lambda functions subscribed to that topic, and as soon as this is published, I will write something into Slack. I will send an SMS to my mobile phone, and I will save the information into the database, but then I decided I will not write it into the database, so I just write it into an S3 bucket. Okay, so that I heard here maybe some functions are possible for you in your application. That's maybe an approach. I also could have done all of these 3 steps inside this Lambda function, so I just made it for myself to also test if that works and that works. Would have been possible in one piece of code. So let's just try that it works, or show you what I have done here. If you look closely, you already saw that there are 4 additional Lambda functions, and these are exactly the, okay, you can see, these are exactly the 4 Lambda functions that I just explained. Let's check here the message to Slack function. What does it do? Can I do that? Maybe a better read, probably. Yeah, it's just plain JavaScript code, nothing special. You can find, if you want to do something like this, you can, enough tutorials how to write to Slack. Just have to activate something on Slack. That's called, how's it called? It's a hook that you have to activate there, and then this is like they provide then a REST service that you can call, and then you can write something to Slack. because it's quite easy. So if you can see, it's about 45 lines of code. How to do it. And then I have, but I will not show it, I have defined the REST API backend with one function in there. And as we are 40 minutes into the talk, I will just show a page, say, let's see. Okay, sorry. And now we should start to see some things popping up. So Slack already informed me the mobile already rang. Yeah, nothing special to show you. Yeah? So just that it works. So we have the information in Slack. If someone wants to check my mobile, he can do. And we probably have the information. Where are we? Oh, I killed it.
Yeah.
Yeah, okay. And we have written it. I'm quite sure it is there in one of those buckets. Okay. And that's it already. I hope that gave you a first overview how serverless functions work, and if that is a possibility in your applications. And I want to thank you for showing up, and I will answer questions if there are any.
Can you automate the process of creation based on a source code repository and some build pipeline or something?
No. Probably. I have not tried it out. As you can upload, I know you can upload the coding with AWS SDK, so probably you can automate that.
And can you also then, because for example this pass to the Slack hook, could be critical to have that in an open repository. Can you have like environment variables injecting that?
Exactly. So I forgot that to mention it. It was on the slides. You're able to pass some or configure some environment variables and then pass them to the function or use them in the function.
Can you say something about the price?
You have to just look it up. It's I think the first, or I read it today. Maybe I can. I think the first 1 million calls a month are free.
Okay.
And
I check it for myself.
yeah, and then it starts with 4 decimals behind the comma for each call, something like this. So they are not very expensive. Yeah.
What kind of providers do offer function-based or serverless computing?
So far, I can talk about 4. So right now, AWS has it, Azure has it, IBM Bluemix has an implementation for serverless, and Google Cloud Platform has it. And for the MSG people, Even the SAP Cloud Platform has it in alpha state. Yeah.
Is it in trial?
It's a lab preview. I don't know exactly.
So it's not released.
Yeah, it's not released. Yeah.
How interchangeable are these services? Do I have to do lots of steps to get it running on different platforms? Is it hard to move between platforms?
Okay, I don't.
Okay.
Probably it's not that hard because you just upload your coding on the other cloud provider, but I don't have any experience inside there.
What's the best approach for debugging those functions if they are in production?
Yeah, there is the best approach is like you often do with JavaScript coding, putting some console logs in there. And as you do not have access to it, you cannot debug it. So debugging goes this way.
But can you simulate to run them locally?
Yes, you can. Or let's say it like this: there are JavaScript frameworks tools out there to do it, to simulate it locally. But they are not provided from AWS, so someone wrote a library for it. Okay, so thank you. And